All right, in this lesson, we are going to talk about the rational parent function, which is y equals 1 over x. And then we are going to do some transformations in graph. So looking at this function, y equals 1 over x, we can plug in specific values for x. And so if I plug in 1 for x, I'll get 1 over 1, which is just 1. If I plug in 2 for x, I get 1 over 2, which is 1/2. If I plug in 1/2 for the x, I get 1 over 1/2. And so when you're dividing by a fraction, remember that is the same as multiplying by the reciprocal, which would be 2 over 1. So that would just give me 2. And so this function is often called the reciprocal function because it takes your input and basically gives you the reciprocal. So if I plug in 2, I get 1/2. If I plug in 3, I get 1/3. If I plug in 1/2, I'm going to get 2. If I plug in 1/3, I'm going to get 3. And so similarly, if we plug in the negatives, we're just going to get the negative versions of those reciprocals. And so when I put this on the graph, I have the point 1, 1. And then when I plug in 2, I get 1/2. But if I plug in 1/2, I get 2. And so as I keep plugging in like 1/3, I would get the 3. If I plug in 1/4, I would get the 4. And so as I keep plugging in smaller and smaller values, this function is getting closer and closer to the y-axis. And so we're never going to actually touch the y-axis, which means x can never equal 0. And we know that because anytime you have division by 0, you have something that is undefined. And so we're not allowed to plug in 0 for x. And so we end up with what is called a vertical asymptote at x equals 0. So that is your vertical asymptote. And then as we plug in larger values, say if I plug in 3, I would get 1/3. If I plug in 4, I would get 1/4. 5, I would get 1/5. If I plug in 10, I get 1/10. So I'm getting infinitely close to the y-axis as well, but I can't plug in a number large enough. Like even if I plug in 1,000,000, I'm still gonna have 1 over 1,000,000. So you're never gonna reach 0. And so we also have a horizontal asymptote at y equals 0. Okay, and so then picking up on the negatives, we have -1, -1, and then -2 would give me -1/2, and then -1/2 would give me -2. So this function is very symmetrical about the origin. And so as we do transformations, this point of symmetry is going to move around, but it's always going to be where the asymptotes intersect. Okay, and so our vertical asymptote was at x equals 0, and then our horizontal asymptote was at y equals 0. And so remember, y equals is always a horizontal line. So y equals 1 would be this line, y equals 2, y equals 3, because they're crossing the y-axis. Whereas x equals 2, x equals 4, x equals 6, those are vertical lines. So it's very important that you have the x equals for your vertical asymptote and the y equals for the horizontal asymptote, because these are lines. And then for our domain and range, we can have every other value except where the asymptotes are. So for example, the domain, we're going from -infinity. This function keeps going to -infinity, but it gets interrupted by this asymptote at 0 and then picks up on the other side and goes to +infinity. And so our domain would be from -infinity to 0, and then union 0 to infinity. We have 2 branches to this function. One over here in quadrant 3, one over here in quadrant 1. And so we just skip over the 0. And then the range is very similar. We're just skipping over the 0 at y equals 0. And so negative infinity to 0, and then 0 to infinity. Making sure to use parentheses because we don't actually equal those asymptotes, we just get infinitely close. Okay, and so as we do transformations, we are going to start moving the points around. We're going to start reflecting them. And so it's going to be important to recognize which transformations you have. And so here's what the transformations look like on some of the functions we've visited throughout the year. And so if we had a +5 outside the function, for absolute value is outside the bars, for outside the square for quadratic, outside the cube for cubic. And so for a rational function, a +5 outside the function would be outside the fraction bar. Okay, and so it's going to be a big +5. And then similarly, we would have a big -5. And then here, a +5 inside the function would be inside the bars, inside the parentheses. For rational functions, we don't have parentheses. That just means it's in the denominator with x. And so that's going to serve as our parentheses. The fraction bar creates our parenthesis. And then a negative outside the function would be outside the bars, outside a square versus inside a square would need the parentheses. And so outside is either going to be completely outside the fraction bar, or sometimes they'll put it in the numerator. Just make sure it's not in the denominator on the x, because inside the parentheses will be inside the denominator on the x. And then a scale factor outside the parentheses, outside the bars, outside the square, would be actually in the numerator. You're going to see it as 5 over x. Whereas if we have a 5 inside the parentheses or inside the function, inside the bars, we would have a 5 in the denominator next to the x. Okay, and so the +5 outside is up 5. The -5 outside would be down 5. The +5 inside, remember, is opposite, left 5, and then -5 would move us right 5. Anything happening to x in the x direction, left and right, is going to be opposite of what it looks like. The way you remember that is your x is a liar. And then here, the negative outside the function, we know that is your reflection over the x-axis. You can abbreviate that r sub x. And then the negative inside would be your reflection over the y-axis. A scale factor outside would be a vertical stretch by 5. You can abbreviate that VS5. And then a scale factor inside would actually be a horizontal compression by 1/5. Okay, and so we're going to see how each of these transformations affect our graph and key attributes. But as far as the vertical asymptote, only moving left and right will affect a vertical asymptote. And then similarly, a horizontal asymptote is only going to be affected by moving up and down. And so the vertical asymptote is what interrupts the domain. And so only moving that will affect our domain. And then similarly, moving the horizontal asymptote is what affects our range. So the horizontal asymptote interrupts your range. The vertical asymptote interrupts your domain. And so those are dependent on each other. And so the only way we can affect our domain and range is really just moving it up, down, left, and right. And so we're going to look at 4 different examples, starting off easy. Okay, and so the first thing I want to do is list the transformations. And so my transformations here, I have a +5 next to the x, so that's going to be your left 5. And then I have a +3 outside the fraction, that's going to be the up 3. And so that means the vertical asymptote is going to move to the left 5 units. So it starts at 0, and it's going to move 1, 2, 3, 4, 5 to the -5. So there's our vertical asymptote at x equals -5. And then the up 3 is what's going to move our horizontal asymptote. Usually it's sitting at y equals 0, but if we move it up, it's going to move to the y equals 3 line. Okay, and so our domain is just going to skip over the -5, and so we can write -infinity to -5, union -5 to infinity using parentheses, and then our range is going to have to skip over the 3. Now, to get the points to be able to graph the function, the default setting, our parent function, he always has a point that is 1 away from each asymptote. And so it's always going to default to quadrants 1 and 3. So 1, you have a point at 1, 1, and 1, -1, -1. Sorry about that. So -1, -1. And so you're going to have that point. As long as there's no vertical stretch or compression or reflection, you're still going to have that situation. And so you can kind of view these asymptotes as your new coordinate grid and this as your new origin. And so I'm still going to have a 1, 1 point and a -1, -1 point. And so you can just create the branches of your function in each quadrant using those as a guideline, following the asymptotes. And so the intersection of the asymptotes is going to be your new origin. That's your point of symmetry. You don't actually have that point, and so maybe don't graph it, but I just wanted to show you that part. Okay, and so here we have 3 transformations happening. One is a vertical stretch by 2, so that's going to affect our points. And then we have a right 1, and we have a down 4. Okay, and so the only transformations that affect your asymptotes are the right and the down. So right 1 moves our vertical asymptote to x equals 1, and the down 4 moves our horizontal asymptote to x equals -4. Not x equals, y equals. So y equals -4 for horizontal asymptote, x equals +1 for the vertical asymptote. So that means my domain skips over the 1, the x asymptote, and then my range is skipping over the -4. Okay, and so usually we would have points in quadrant 1 and 3 that's 1 away from each asymptote, but with the vertical stretch by 2, that means you're going to have a point that's going to be at 1, 2, and then 2, 1 from the origin. Okay, so treating this as our new origin, we're going to have a point that's at 1, 2, so 2 away from one of the asymptotes, and then we're going to have a point at 2, 1. So when one point is 2 away, the other is 1, 2, 1. So those are going to be how you get 2 points in each branch. It's kind of confusing at first. So just think of it as 1, 2, and 2, 1. And so same in the quadrant 3. So we're going to go 2, 1, and then we're going to go 1, or 1, 2. So whenever you have a vertical stretch or compression, you're actually going to get 2 points on each branch from that, rather than just 1, 1. All right, amping it up a little bit, we've got 4 transformations now. We've got a reflection across the x-axis. We have a vertical stretch by 3. I'm going to use a different color. There's our reflection across the x-axis. And then we have our vertical stretch by 3. and then we have left 2, and then we have up 4. Okay, so let's start with the familiar. So the left 2 is going to move the vertical asymptote to x equals -2. And then the horizontal asymptote is going to move up 4. So y equals 4. And so we can already do the domain and range. Those are the only excluded values. So skipping over x equals -2. And then skipping over y equals 4. Now we just need to get some points. Okay, so we talked about the vertical stretch by 3 with the reflection. A reflection over the x-axis actually does the same thing as a reflection over the y. So you don't really have to specify or understand the difference. Just know that if you have a reflection, instead of being in quadrants 1 and 3, as we have been, that's default, 1 and 3, we're actually going to be in quadrants 2 and 4. So that's what the reflection is going to do, whether it's a reflection across the x-axis or the y-axis, that puts your branches in the opposite quadrants. And so the vertical stretch by 3 means I'm going to have a 3-1 point and a 1-3 point from my new origin. Okay, so 3-1 and 1-3, but we don't want quadrant 1. We want these to be in quadrants 2 and 4. So 1-3 and 3-1. In quadrant 4, 3-1, 1-3. And that's it. All right, last one, most complicated one. Whenever you have a number being multiplied by x, you actually have to factor that number out. And so I need to add parentheses to separate that -2, and then I need to divide this 10 by that -2. Sometimes you might even be left with a fraction there. And so factoring out the -2 would leave me with an x minus 5. And so if you were to graph this function, say like in a calculator, you would see that it's actually only moved right 5. It looks like left 10, but when you put it in the proper form by factoring out that -2, you'll see that it's actually right 5. And so listing the other transformations, we have a reflection across the y-axis. That means I'm going to be in quadrants 2 and 4. We have a horizontal compression by 1/2. And so just like if it was a vertical stretch or vertical compression, that means I'm going to have the point 1/2, 1, and 1, 1/2. Any scale factor, regardless of where it's at, is going to create these 2 points in each branch. And then we have our right 5 from this, minus 5, and then lastly an up 3. Okay, so start with the familiar. Right 5 is going to move the vertical asymptote to x equals 5. And then up 3 is going to move our horizontal asymptote to y equals 3. So that means our domain is skipping over the 5. Our range is skipping over the y equals 3. Okay, so now we got to get our points. We know it's going to be in quadrants 2 and 4. And then we're going to have a 1/2 1 and then a 1, 1/2. For each of these scale factors, one of your coordinates is going to be 1, and the other is that scale factor. So 3, 1, 1, 3, 2, 1, 1, 2. So just using the scale factor as one of the coordinates. And so here it's 1/2, but same thing, the other coordinate is 1. So going to your new origin, you're gonna go over 1, up 1/2, then you're gonna go up 1 over 1/2. So you're getting really close to the asymptotes. That's what a compression is going to do. Oh, wrong quadrant, sorry about that. And so over 1, up 1/2, over 1/2, up 1. When one of your coordinates is 1/2, the other is 1. And this is still like in reference to the new origin where the asymptotes intersect. So over 1, down 1/2, down 1 over 1/2. Takes practice, but you'll get it. Right? And so that's how you graph rational functions using transformations. And then next time we're going to look at more general rational functions.